Okay, hey guys, how's it going? So, we're right here on 2.3 scale triangles. So, it gives us an assortment of triangles labeled O through H, okay? And it says your teacher will assign you two of the triangles to look at. For this example, let's just go ahead and say you need to compare all of them to O, which is the original. This is our original triangle, okay? We're going to be comparing the rest to this one. So, we need to answer these three questions, 1, 2, and 3. For number 1, it says, for each of your assigned triangles, is it a scaled copy of triangle O? Be prepared to explain your reasoning. So, what we are going to do is we are going to look at O and see which ones are similar to it. A good hint for us to start off before we begin is, can you guys list what kind of triangle is that? If you did not already know, this is a right triangle. How do we know it's a right triangle? Because it has that box in the bottom corner. The box signifies 90 degrees. So every triangle with the box is 90 degrees. So we know B is a 90 degree, C, G, D, and H, and E. So we should probably start with those first, okay, since most likely they might be similar. Again, if we do not remember what a scale drawing is, let's go ahead and let me just draw two triangles, for example. Okay, I know they're kind of ugly, but let's say this one is 2, 3, and 4. That doesn't make sense, but let's just say that's 2, 3, and 4. Okay. A scaled factor means the number each side is multiplied by. So let's say for this example that I have right here, example, this side right here is 4 on the new triangle. This is the old triangle. This is the new triangle. So let's go ahead and look at these two triangles right here. We have the number 2 and we have the number 4. Using only multiplication, because in scaled factors we're only dealing with multiplication or division. How can we get to the number 2? So we know 2 plus 2 equals 4. That's right. But again, like how I said, in scaled factoring, we can only use multiplication or division. So what is another way that we can use 2 to get to 4? Well, we can use 2 times 2 equals 4. That works. So that means our scaled factor in this example would be 2. So if we wanted to know this side, we would have to multiply by 2. That would give us 8. And if we wanted to know this side, 3 times 2 give us 6. This is our new triangle, and since every side is multiplied by the scaled factor, this is indeed a scaled copy. So let me go ahead and write that down here. Same scale factor equals scaled copy. Now you may be wondering, well, these triangles already have numbers. How do I figure this out? So this is how we would do it. I'm going to look at O and I'm going to look at E because right off the bat I know these are answers. I'm going to figure that out. So I'm going to look at my 8 and my 4 and I'm going to do something with those. Since we're not multiplying, because multiplying is to find the unknown side, how we did here. If we already have two sides, we can divide. 4 divided by 2 equals 2. That's our scale factor. 8 divided by 4 equals 2. That's our scale factor. And then 6 divided by 3. That's 2. Scale factor. Okay. So that's what I'm going to do here. I'm going to take these two sides and see if there's a scale factor. 8 divided by 4 equals 2. That works. Okay. Now let me check 5 and 10. 10 divided by 5 equals 2. Yep, that works. Let me check the last side. 6 divided by 3 equals 2. Yep, this works. E is a scaled copy. Scaled copy because they have the same scale factor, which is 2. Okay? So your job is to figure out B, C, G, D, and H. A and F, but like we were talking about in the beginning, those are not right triangles, so most likely they are not going to be scaled copies. That is all for question number 1. Now, question number 2 says, as a group, identify all the scaled copies of triangle O in the collection. Well, what do you know? These two kind of go hand in hand. If you do number 1, you can answer number 2. Discuss your thinking. If you agree, disagree, that is all on your own. Okay, if you agree or disagree. And then number 3, list all triangles that are scaled copies in the table. Record the side lengths that correspond to the lengths of the triangle O listed in each column. So I'll go ahead and list E for you guys. I'll show you guys how to do that. So triangle E. The side that had a 3, which was this bottom side right here, was the number 6. So I'm going to go ahead and write a 6. For the side 4, I had an 8. And for the side with the 5, the hypotenuse is a 10. Okay. So you're going to do that with every triangle that is similar to the original. Okay. And then in number 4, it says it wants you to explain or show how each copy has been scaled from the original. This will be covered in the triangle. And also, you should be able to explain it. So in part number 4, just give a couple sentences on how. Man, I messed it up. Good thing I teach math, not English. Sentences, I think. Okay. If you have any questions, email me, and we'll go ahead and clear this out.